Hello, and welcome to G Fun Facts Online. Today, we're diving deep into a world that's invisible to the naked eye, but shapes everything around us. I'm talking about quantum mechanics. Believe it or not, this mind-bending field is celebrating a huge milestone. A century ago, our understanding of physics was turned on its head with its birth, and what started as some really puzzling ideas about tiny subatomic particles has exploded into a cornerstone of modern science and tech. It's so pivotal, in fact, that the United Nations has declared 2025 the International Year of Quantum Science and Technology, marking 100 years since its formal inception in 1925. This isn't just a look back. It's about how quantum science is lighting up our future. It all kicked off with absolute legends like Max Planck, Albert Einstein, Niels Bohr, Werner Heisenberg, and Erwin Schrödinger. These brilliant minds dared to explore the super weird rules governing the universe at its tiniest scales. They found a realm where particles could be in multiple places at once. That's called superposition. They discovered that just looking at something could change it, and that particles could be mysteriously linked across vast distances, a phenomenon we call entanglement. Crazy, right? These ideas were baffling at first, but they turned out to be not only real but incredibly powerful. The first wave of understanding, often called the first quantum revolution, actually built the world we live in today. Think about it. Transistors and microchips, the hearts of our smartphones and computers, they run on quantum principles. Lasers, used in everything from eye surgery to Blu-ray players and those vibrant LED screens, all direct spin-offs from quantum theory. Even medical marvels like MRI scans wouldn't exist without it. And get this, the GPS that guides you on your road trips relies on atomic clocks, which are super precise thanks to quantum insights. This era was all about observing these weird quantum effects and using them to invent game-changing tech. But hold on, because we're now riding the wave of the second quantum revolution. This is where things get even more exciting. We're moving beyond just observing. We're actively grabbing quantum systems by the metaphorical collar and telling them what to do. Scientists are now building technologies that directly use the most bizarre aspects of quantum mechanics, like superposition and entanglement. This revolution is set to redefine entire industries and help us tackle some of humanity's biggest challenges. Leading the charge is quantum computing. Now, your regular computer uses bits, which can be a 0 or a 1. But quantum computers use qubits. Thanks to superposition, a qubit can be a 0, a 1, or both at the same time. This means quantum computers can perform calculations that would take the fastest supercomputers we have now literally ages to complete. What can we do with this kind of power? Well, for starters, revolutionize drug discovery and materials science. Imagine simulating how molecules interact with perfect accuracy, speeding up the creation of new medicines tailored to your DNA, or designing incredible new materials like room-temperature superconductors. Quantum algorithms could also optimize complex systems, like global logistics, financial trading, or even climate change models, with mind-blowing efficiency. And for all you AI fans, quantum machine learning could give artificial intelligence a massive boost, leading to smarter robots and maybe even artificial general intelligence. It's not all smooth sailing. Building large, stable quantum computers is tough due to issues like scalability and error correction. But progress is rapid, with hybrid systems already speeding things up, and the global market is booming with investment. Next up, quantum sensing. These are sensors that use quantum tricks to measure things with unbelievable precision. We're talking about detecting tiny changes in magnetic fields, gravity, temperature, or time. In medicine, this could mean spotting diseases like Alzheimer's way earlier by picking up on subtle changes in the body, or even improving MRI to see single cells. For navigation, quantum sensors could give us super accurate positioning even when GPS is out, which is vital for autonomous cars or exploring tricky terrain. They could even help us find mineral deposits, monitor volcanoes, or maybe even detect dark matter. Just recently, researchers at USC demonstrated a new quantum sensing technique that's even better at dealing with environmental noise, which could really speed up advancements. Now, With great quantum computing power comes great responsibility and a potential threat to our current digital security. Powerful quantum computers could theoretically crack the encryption that protects our online data. But don't panic. Scientists are on it, developing two main solutions. First, post-quantum cryptography, or PQC, which involves creating new classical encryption methods tough enough to resist both classical and quantum computers. NIST, the National Institute of Standards and Technology, is leading the charge to standardize these. Second, there is quantum key distribution, or QKD. This uses quantum mechanics itself, like entanglement, to create communication channels that are theoretically unhackable. Any attempt to eavesdrop would disturb the quantum state and alert the users. The race is definitely on to get these new security measures in place. And what will all this quantum tech be made of? Quantum materials. These are substances with unique electronic and magnetic properties that come directly from quantum effects. Think superconductors, topological insulators, and super-thin 2D materials like graphene. They're essential for building the hardware for all these quantum technologies and promise faster electronics, revolutionary solar energy materials like perovskites, next-gen batteries, and even spintronics, which uses electron spin instead of charge for ultra-low power devices. The impact on healthcare alone is going to be transformative. Beyond faster drug discovery and better diagnostics, quantum principles could allow us to personalize medicine by analyzing huge amounts of genetic data to tailor treatments specifically for you. It could give us new tools to understand the brain and develop treatments for neurological disorders. And quantum-enhanced imaging could provide surgeons with real-time, super high-resolution views during operations. Of course, this quantum revolution isn't without its hurdles. The technology is expensive, we need a whole new generation of skilled scientists and engineers, and there's a risk of a bigger global digital divide if we don't ensure everyone can access these advancements. Plus, some fundamental mysteries about quantum mechanics, like how it fits with gravity, are still being explored. That's why international collaboration, like the International Year of Quantum Science and Technology, is so important to tackle these challenges and make sure quantum mechanics benefits everyone. So the first 100 years of quantum mechanics gave us a world powered by its principles, from the sunshine to our smartphones. Now the second quantum revolution is in full swing, building a future where quantum computers solve problems we once thought impossible. Quantum sensors reveal the universe's hidden secrets, and quantum communication keeps our information safe. As we explore this amazing, strange, and powerful realm, the next 100 years promise even more mind-blowing discoveries and technologies that will continue to reshape our reality in ways we can only just start to imagine. The journey into the quantum century is a thrilling testament to human curiosity and our drive to understand the universe and use its laws to build a better future. That's all for this episode of G Fun Facts Online. Thanks for tuning in, and until next time, keep wondering.